1B, proposition. Sometimes we have arguments that are built for statements that can either be true or false. For example, if we look at the argument, you don't like pasta. Now, this part where the argument says you don't like pasta, that could either be true or false. You could not like pasta, or it could be false where you really do like pasta. The second part of the statement where you must like hamburger, that could also either be true or false. These type of arguments are called propositions. And it has a true or false that can be true or false. Now you'll notice, in order for something to be a proposition, for argument to be a proposition, it usually has a complete sentence structure. So for example, Justin is standing in the hallway. That could be true, right? We can go outside and find Justin there. Or it could be false. We could go outside and he's not there. 2 + 1 = 5. That is also a proposition. Now, in this case, it's a false proposition because 2 + 1 is not equal to 5, but it's a proposition nevertheless. We could have something that's not a proposition. Did you eat lunch yet? That's a question. That's not a proposition. There's no true or false to it yet. A book on the table. What about a book on the table? Are you trying to say that there is a book on the table, or there is not a book on the table, right? Whether we sort of make a proposition that way would come up with different true or false value. So these ones where it's kind of an incomplete sentence or a question, these are not propositions. We're going to talk about how to change these propositions and how to join them together. And we want to observe how does the true and false value change when we do these operations on a proposition. We can do something very simple that's called a negation. Negation means the opposite. So if I have a proposition, Justin is standing in the hallway, the negation of that is just Justin is not standing in the hallway, right? When we add the word not, that's what negation is. Do the opposite. 2 + 1 = 5. Then the negation is 2 + 1 does not equal to 5. And here in math, we use a not equal to symbol to represent it. Finally, if I use P to represent a proposition, this is a little bit like algebra, where we use X to represent a variable. Here we use P to represent an unknown proposition. Then the negation of the proposition can either be not P, or sometimes we use a squiggly symbol, a tilde symbol, to represent it. Now, you won't be seeing this a lot in our course. In our course, we'll typically use not P to represent the negation of a proposition. A proposition will have a truth value of either true or false, right? A proposition can either be a true statement or a false statement. A truth table shows whether a proposition is true with all the different possibilities that we have into the different part of a more complicated proposition. So here, let's think about a more complicated proposition, the negation case. Now, in the negation case, we want to see how a true value would change when I do a negation. So for example, we could have our proposition could be something like Vancouver is a city. And now, of course, it's true, right? Vancouver is a city. The negation of my proposition, instead of Vancouver is a city, it's now adding a not to it. Vancouver is not a city. Now, of course, Vancouver is not a city is false. So you notice that the negation changes the truth value from true to the opposite value, false. And we can do the same thing, right? We can think about a false statement where Vancouver is a sound, Vancouver is not a sound, and of course that's true. And so the negation changes the truth value from true to false and false to true. So what you'll have to know now is for these different combinations or these different operations, like the negations, you have to know how it changes the truth value. The next type of statement is called an and statement or conjunction. And conjunction statement is where we have two parts, right? Let's say you go to a restaurant and you order a hamburger and a drink. Now, of course, if I order a hamburger and a drink, I need to have a hamburger and I need to have a drink. That's when I'm satisfied, right? I order a hamburger and a drink. Now, if only the hamburger comes and the drink didn't come, then I'm not happy, right? My order is not filled. Same thing when I only have the drink but not the hamburger, right? My order is not filled, false, incomplete. And if I don't have any of them, that's also false. So you'll notice in the conjunction, when I need one and another, that I need both of them to be true in order for the conjunction statement to be true. And this truth table over here is telling you how the conjunction produce different type of truth value based on the different combination of P and Q. Now we'll show you how to use the idea to analyze some of the statements that we have. The first one over here is that the capital of Canada is Ottawa, and the capital of France is Paris. Now, we'll try to give you statements that's really easy for you to tell whether the statement is true or false. In this case, the capital of Canada is Ottawa, and the capital of France is Paris. Now, both of them are true, so the whole statement, the capital of Canada is Ottawa, and the capital of France is Paris, that's true. Now, for the second statement over here, the capital of Canada is Ottawa, and the capital of France is Burnaby, we know the second part, the capital of France is Burnaby, is false. So the whole thing, now remember, a whole statement can only have either a true or a false value. Okay, it cannot be both. It cannot be true and false. So in this case, because the first part is true, the second part is false, the whole statement is false. It's like only the hamburger came and I don't have my drink. So together, the conjunction is false. The next type of statements I will talk about are the or statements. Or statement is called a disjunction. And we will have P or Q. Now imagine you go to a restaurant. If you go to a restaurant with your friend, and your friend is going to make the order for you. And your friend asks you, what would you like? And you said, I like either chicken or fish. Chicken or fish. So if your friend got you chicken and got you fish at the same time, we would be like, yeah, good friend, chicken and fish. But if you only tell your friend, I just want chicken or fish, if your friend brings you the chicken, but no fish, you're happy. If your friend didn't bring you any chicken, but bring you fish instead, you're still happy because your instruction was chicken or fish. As long as you have one of them, you're a happy person. The only time where we have a false result is if your friend comes back and brings you neither. So the or statement is false if both of them are false. Now, it seems easy to understand in this situation, but sometimes our statement will be really weird, and it might be really difficult to think about. So just go back to the truth table if needed. Now, in real life, we have two types of or. One is an inclusive or, like in this case, like you can go see an 18A movie if you're an adult, or if you're people accompanied by an adult. All right. So if you're an adult, that's fine. If you're a kid going with an adult, that's fine. If you're an adult going with an adult, that's fine too. But often, if we're in a restaurant, we will say you can have a pop or a juice. Now, you can have a pop, you can have a juice, but you cannot have both. Now, this is called an exclusive or. In logic, or in our class, whenever we see the word or, we're going to think of it as the inclusive or. Inclusive or is used in logic. It's also used mostly in computer science as well. And the exclusive or typically has another name, right? Has a slightly different symbol to it. Let's look at the statement. Airplanes can fly or cows can read. Before you jump into a conclusion, always try to break down the statements into its individual parts. Here, the parts are the airplanes can fly or cows can read. Airplane can fly is, of course, true. Cows can read is false. Now you have to think about what happens when I have a true part and a false part in the or statement. In an or statement, I just need one of them to be true, and that's good enough. So in this case, the statement is true. It's like telling your friend, I just want chicken or fish. Your friend brings you the chicken, but didn't bring you the fish. The last big type of statements that we'll use is called the if-then statements. If-then statements are called conditional propositions. And it's made out of two parts. The first part, the one that comes after if, you are sick in this case, that's called the hypothesis. And the conclusion is what comes after the then. For a conditional statement, the truth table is a little bit strange. You'll notice it's true everywhere except for the case that's true and false. It's easiest to think about considering the statement, if you are sick, then you need to stay home. Now, if you are sick and you stay home, that's fine, right? You didn't break the rule. If you're sick, but you didn't stay home, you went outside, then you break the rule. And it's like false. You broke the rule. If you're not sick and you stay home, that's fine, right? The rule doesn't apply to you because you're not sick. If you're not sick and you didn't stay home, that's okay. Because you're not sick, the rule sort of never applied to you, and the rule is still satisfied. So you notice if we go through all four situations, the only time where the rules are broken is when you are sick and you did not stay home, where the second part is false. Let's look at this statement. If 2 plus 2 equal to 5, now if we look at 2 plus 2 equal to 5, this part over here is false. 3 plus 3 equal to 4, that's also false. But if we look at the first part, if the first part is false, then we don't really have to worry about the rest of the conditional statement, right? Because then the conditional statement does not apply. Right? Think about the original statement that we use as an example. If you are sick, but if you're not sick, then it doesn't matter what happens after. In this case, because both of them are false, the whole conditional statement is actually true, right? The statement here, the hypothesis is not satisfied. Then it doesn't matter what happens after. If the first part is false, it doesn't matter what happens after. And that's very important for the conditional statement. And that's the part where it's easy to make a mistake. And if you ever forget, just think back to the statement. If you are sick, then you need to stay home. If we are not sick, then it doesn't matter what we do. Right? We won't break the rule. Finally, we're going to use this opportunity to introduce some more complicated propositions. There are a few different ones over here. Converse is something called if Q then P. Let's say if I have a statement, if you're sleeping, then you're breathing. If I flip it around, that's called the converse. If you're breathing, then you're sleeping. Inverse is simply changing doing negation to both parts. So instead of sleeping and breathing, then breathing, we're doing if you're not sleeping, then you're not breathing. Contrapositive is where we add the word if we do negation, but we switch the order around. So we're saying we're taking the breathing, we're putting in the front. If you're not breathing, then you're not sleeping. What we're going to be showing you here is to show you how to come up with a truth table of a more complicated statement, like the contrapositive. When we write the truth table, always think about all the different parts, all the different individual propositions that makes up the whole thing. In this case, we have P and Q, only P and Q. We think about all the different combinations we can have of their true values. They can both be true, true, false, false, true, false, false. Now, it's really difficult to come up with the result right away. So what we want to do is we want to find out each individual part. It's a little bit like doing math. If you see a bracket, do the bracket first, right? Do this thing on the inside first. So here we're going to find out what is not Q. And we're going to find out what's the true statement for not P. And we're going to do both of them before we find out what happens in the contrapositive. Now, when I do the negation of Q, we're going to change this true false value from true to false, right? We're going to do the opposite. We're going to do the opposite, not for any one of these, but for Q specifically. So when I have false over here, that's going to change that to true. If I have true over here, that's going to change it to false. And when I have false over here, it's going to change it to true. When I do the negation for P, I'm going to look at the true false value for P, and I'm going to do the opposite. True become false. The true over here will become false. The false over here is going to turn into true. And the false over here is going to turn into true as well. Now let's look at the contrapositive when we put everything together. Now in this case, we can think we already figured out what happened in the two parts, right? We already know what happens here and here. We know we're looking at a statement where if something is false, then something is false, and we're trying to find out what does that give you for your conditional statement. And for the next one, for the next line over here, we're trying to think about what happens in my conditional statement if I have the first part, the hypothesis being true, and then the conclusion being false. Right, and we can sort of see where we're going with this, right? Here we have like false and then true, and then here we have true and true. Now, of course, this is not what we're going to write. We have to then think back to the conditional statement. Or just think back to the conditional statement. Now, remember, the conditional statement is false when I have this. When I have if true, then false. If you're sick and then you didn't stay home, that's when you break the rules. That's the only time where it gives you a false, and everything else is true. And so this is what we do to find out a more complicated proposition like the contrapositive. We have to go through the individual parts first and then combine everything and think about what happens in the final step when we have a conditional statement. Now you'll notice what we just wrote down here so far, the true, false, true, true, that's what we have in the contrapositive. And you'll notice that's exactly the same as the conditional statement. In this case, we call these two types of statements logically equivalent. So if you look at our example here, if you are sleeping, then you are breathing. And the contrapositive here, if you're not breathing, then you are not sleeping. These two statements are logically the same. It's the same thing. If you say these two sentences, these two arguments, they're exactly the same.